Okay, so this video is for the CSC-1013 Intro to Computing class, and it's an introduction to the different number systems that computer scientists and programmers and other folks in software development face on a daily basis. So there are really four key number bases that are important. So there's obviously binary, and that's base 2, right? And typically people will write like a big B or a little b in front of a number. And it'll be like 1001, right? For a 9 there. And it's just the symbols are 0 and 1. That's it. Then typically there is the octal number system, and for you folks in Intro to Computing, this is a very limited use, but that's base 8. And that's going to have the symbols 0 to 7 basically in it. So sometimes people will prefix values in octal with a 0, so it'd be like 3, 5, 7. Right? Sometimes they will put a Q, though that's really not typically done anymore. Alright, the number system that you're all familiar with is decimal, and that's base 10. Digits are 0 to 9, and obviously we write the numbers as they are. So we might put a D with the number, I guess. I don't know. It doesn't seem like. The other way, obviously, to do each of these values, right, and from a more mathematical perspective, is we might say 1001 subscript 2, or 357 subscript 8, or 129 subscript 10, right? Decimal being implied. And the final one is hexadecimal, all right? So the hexa, right? 1610, right? Base 16, 0 to 9, and then we have the symbols A, B, C, D, E, and F. Right? And there you might get something like, alright, you generally say 0x as a preface, right? Or you might use H either before, or you might use a little h afterwards, something like that. And you might say like dead beef, right? That's a favorite one of mine. Although more realistic is to have like maybe 1, 3, 5, 7, 9, I don't know, AC. You could have something like that too. Pretty large guy. You could also take something like A7C or something like that and put a base of 16 on it. So those are really the four important number systems. So if you think about it, taking that 123 from earlier, in a decimal system, that 123 really has weighted positions, right? So obviously the 3 is in the 1's position, right? The 2 is in the 10's position, and the 1 is in the 100's position. And we would say that this is 10 to the first, 10 to the 10 to the 0, 10 to the first, because that's 10s. The 1s would be just anything to the 0 is 1, right? So 10 to the first, and then obviously 10 to the second for the 100's position. And then obviously from this we could say 1 times 10 to the second plus 2 times 10 to the first plus 3 times 10 to the 0, right? So there we get our 100 plus our 20 plus our 3, right? 123. And obviously we can have decimal values, or fractional values I should say, after that, and then those would have 10 to the negative first, 10 to the negative second, 10 to the negative third, and so on, right, to it. Let me see here for my notes. And obviously we calculate each of these in the same way. If there was a decimal value, we would just do it the same, right? So trying to think. I had that. That would be 1 times 10 to the 4th plus 9 times 10 to the 3rd. Just really hard to see now because I've moved it out of frame, right? Plus 7 times 10 to the 2nd. Plus 7 times 10 to the 1st. And just to make sure from earlier, we see how we got the hundreds, the tens, and the ones from here, up here for each of these spots to get our 123. Down here, we have that. So it takes us thousands for 10, I'm sorry, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, 10 to the 0. And then we'd want to go ahead and add to that 1 times 10 to the negative 1st, right? Plus 2 times 10 to the negative 2nd, plus 3 times... Whether you do the multiplication symbol or that doesn't matter as long as you can kind of show the work. Times 10 to the negative 3rd, okay. And then we can just go through and get those values, right? So we get the 1,000 plus the 900 plus the 70 plus the which again, the camera in frame there, right? And then we have, let's see here, the 7. And then obviously we have, for the remaining part of that here, the 0.1 plus, let's see here, we have the 2 times the 10 to the negative 2nd. So let's see here. Let me check. Then on the other fractional parts, the 2 will be times 10 to the negative 2 will be 0.02, and then the 3 times 10 to the negative 3 will be 0.003. So, and then that'll get you back all your actual parts up here from above. Should be 900 there, and hopefully it gets you started. So one of the number systems I mentioned earlier was the binary number system. So, and we had talked about in class how it's just more efficient for computer systems to use binary logic because it's easier to represent 2 voltage levels than, say, 10 voltage levels in some of the early decimal computers. And having 2 voltage levels allows us to easily represent 2 different values. There could be any 2 different values, but by convention we just use 0 and 1 because that kind of makes it easier for us to wrap our heads around it. And those are also the digits used in the binary number system, right? So since there's a correspondence between logic levels used in digits in the binary number system, computers naturally use the binary system. Shouldn't come as a surprise to you. So when you have systems like that, you'll find out that you'll have the typical, placeholders, right? So you have 2 to the negative 2, which is like 0.25, 2 to the negative 1st, which is like 0.5. You have 2 to the the decimal point was done way too early, and you have 2 to the 0, which is 1. You have 2 to the 1st, which is 2. So the 1s, the 2s, the 4s for 2 to the 2nd, 2 to the 3rd for the 8, let's see here, 2 to the 4th, the 16, 30 seconds are 2 to the 5th, and 64 are 2 to the is 2 to the 6th, so on and so forth. All right. And just like with the decimal number system, we can kind of divide those up there. All right. Let's see here. So again, if we want to convert from, say, a binary value to decimal, and there's a number systems practice sheet you can download for this. For instance, like we want to convert 110 from binary to decimal, then all we have to do is take each digit binary value and then multiply by its appropriate positional place. Like here's 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, right? So we say 1 times 2 to the 5th, and then 1 times 2 to the 4th, and then if it's 0, we just leave it out. 1 times 2 to the 2nd plus 1 times 2 to the 1st plus 1 times 2, 0, 0. Okay. We could put it down, but then obviously anything to the 0 is just 0, 0 times 0, or 0 times anything, 0, right? So by that identity. So then we just 2 to the 5th, 32, plus 2 to the 4th, 16. That's why memorizing these charts might help you a little bit. Plus 2 to the 2nd, 4, right? Plus 2 to the 1st, 2, right? And then we'll just add those up, get 54. Okay. And we did the other one from the practice sheet, 1 0 0 0 1 1 1. Then again, it's just 1 times 2 to the 0, to the 1st, to the 2nd, 3rd, 4th, 5th, 2 to the 6th, all right? And then we leave those 3 out, and then we do 2 to the 2nd. We don't even really need the 1 times. It just kind of helps us think in terms of any number base. Plus 1 times 2 to the 1st, plus 1 times 2 to the 0. Right? So there, that gets us 2 to the 6, 64, right? Plus 4, plus the 2, plus the 1, which is 71. Now, let's say we wanted to go the other way. We wanted to go from decimal to binary, all right? So, all right, let's say we want to do 23 in binary and want to figure out what that is in decimal. Right? Okay, so first thing, we want to write down our decimal value, and each time through we want to divide by 2. So divide by 2, we'll get a quotient of 11 and a remainder of 1. Again, divide by 2, we'll get a quotient of 5 and a remainder of 1. Divide by 2 again, we'll get a quotient of 2, remainder 1. Divide by 2 again, we'll get a quotient of 1, remainder 0. And then again, we'll divide by 2. Doesn't go into it at all, so we get 0, remainder 1. And if we follow our places back up, like this, we get 1 0 1 1 1, which we can then write out as 1 times 2 to the 4th, 2 to the 4th, plus 1 times 2 to the 2nd, plus 1 times 2 to the 1st, plus 1 times 2 to the 0, or 16 plus 4 plus 2 plus 1, which is 23. That checks our workout. All right, and that gives us the answer up here. So let's try another one here. Let's try 76 decimal to something in binary. All right. So here we got, let's see if I can get this on the screen a little better. 76 divided in 2, quotient of 38 with a remainder of 0, right? That should go in there precisely, yep. And then divide by 2, we should get we go in there once, and that'll be 18, and that'll go in there 9 for the quotient. and then that'll give us a remainder of 0, right, because that's 1938. All right, divided by 2, and then here, it's a little bit neater. I have horrible handwriting. Sorry about that. I should go in there, not at all, the first digit, and then let's see here, 8, 9, right, and then a remainder of 1, and then so 9 quotient, and divide that by 2 again. That'll give us a quotient of 4, all right, and a remainder of 1. Now divide that by 2. That goes in there. That gives us a quotient of 2 and a remainder of 0. Divide by 2. That'll go in there once. Give us a remainder of 0. Divide by 2. Doesn't go in there. It gives us 0. So a remainder of 1. So again, just reading this from, I call it the bottom to the top here. So 1, 0, 0, 1, 1, 0, 0. 1, 0, 0, 1, 1, 0, 0. Alright. And again, 2, 0 to the first, 2 second, 2 third to the 6. So I can shorten this, say 2 to the 6, 2 to the third plus 2 to the fourth. It gives me 64 plus 8. I'm sorry, it should be to the second there. And plus 4 there. And then the 74, 76, right? Whoops. And I kind of broke that paper there, but it's it. But it verifies our work on that problem. Okay, so now let's look at binary addition and binary subtraction, which are two sort of important operations with any number system. And we'll also do this later for hexadecimal when we get to our discussions on that. So let me just make sure I'm kind of staying in frame on this. So let's say we had from our practice worksheet 1101, and we want to add to it 111. Right? We're just going to, again, we're just going to start adding. But again, all we have are the digits 0 and 1. So 1 plus 1 is 0. We're going to carry our 1. 0 plus 1 is 1. But we have to add our 1 that we carried. So again, that's 0. We carry our 1. We have our 1 plus 1 is 0. Add 1. Alright. And then that's going to give us a 1. Alright. In this column here. In our 2's column here. Or 4's column. 1's, 2's, 4's. And again, that's going to cause us to have to do a carry here. So 1 plus the 0, right, because that's implied there being leading, is still a 1. 1 plus a 1 is a 0. And then we carry into this position here, which has sort of this implied 0 here, a 1. And 1 plus the 0 is just the 1 there. Right? And you think about it, so that's 8, that's 12, right? That's 13. And that's 7 there, so that's 20, right? Now, does that really make sense with what we have here? Alright, well, we have 0, 1, 2, 3, 4, so we have 16, right? Plus our 4, right? 8 and 4, so that equals 20, so that kind of all matches up there, right? If you want to check your work, that is, and I really highly recommend that you do check your work. And let's try another one. So 11011. Let's add to that 10011. Right. So again, we have the 1 plus 1 0, carry your 1. 1 plus 1 is the 0 plus the 1. There's a 1. All right. And now we still have that carry we have to do because we're going over to another place. We're going from a lower position to a higher position. 0 plus 0 is the 0. Add the carried 1. So there's your 1. 1 plus the 0 is the 1. 1 plus the 1 is the 0. Carry a 1 into our implied position here. And then we have 1. So 1 0 1 1 1 0. All right. See, that makes sense. All right. So 0 1 2 3 4. So we get 16 8. That's 24. Our 26 27. All right. And then we have 16 8 or 16 2 for 18. Add one more for 19. All right. So 6, carry your 1 there in decimal, right? so 46. And let's see what we got here. 0, 1, 2, 3, 4, 5. So 2 to the 5th, 32. Plus the 8 there, right? Plus 4, plus 2. So let's see here. That gives us our 40, 44, 46. There we go. We checked our work. So, all right. And then let's see here. Binary subtraction will be next. Okay. So now let's take a look at binary subtraction. Let's say I wanted to subtract 1, 1, 1, 0, 1 minus 1, 1, 0. That's in your practice sheet. So we'll start as before. 1 minus 0 will be 1 here. We can't take 0 minus 1. We need to borrow, right? So we go from the 0, 1, 2's column here. Or I'm sorry, the 1's, 2's, 4th column here. So we make that a 0. So then we act like we're borrowing, all right? Well, we act like we're putting a 2 here, even though there isn't a 2 in that decimal system. Well, there isn't a 10, right, in decimal when we subtract and we borrow, but we write that down anyhow. So, or there isn't a symbol 1, 0, right? So we just write a 2 down here. So 2 minus the 1 is the 1, and then we can't take 0 minus 1 here. So we need to borrow again from the 1, 2's, 4's, 8's column. So we got that as a 0. We mark that as a 2. The 2 minus the 1 is the 1 here. Now 0 minus the implied 0 that's there is our 0. All right. And then 1 minus our implied 0 there is just 1. Right? So let's check. So we got 0, 1, 2, 3, 4. So 16, 20. 24. Let's see here. That's here. 16, 8, right? 0, 1, 2, 3, 4. 16, 24, 28, 29, right? Yeah, sorry, my bad. And then we have 6 here. So we should have a 23 in decimal. So let's see what we got. We got 0, 1, 2, 3, 4. 16, no 8. We got a 4, we got a 2, we got a 1, and it looks like 23 to me. So, alright. So then we come over here to this next value, our next example from our number systems practice worksheet. And there we have 1, 0, 0, 0, 1, 0, and we'll subtract from that 1, 1, 0, 1. Okay. So again, we can't do 0 minus 1, so we're going to borrow here. I'm sorry, we're going to borrow here and then put our borrowed value up here. So 2 minus 1 is 1. 0 minus 0 is 0. We can't subtract 0 from 1. So we go over and keep going over till we can't go over any further and borrow from there. Alright, so 0, we got 2, but we got to borrow, so 1. Put that as a 2 here, borrow from that to get a 1. Put a 2 there. Alright, so now I got 2 minus the 1 is the 1, 1 minus the 1 is the 0, 1 minus our implied 0 is a 0, and 0 minus our implied 0 is, let's see here, 0, 1 minus our 0 is our implied 1, and 0 minus the 0 is 0. So, sorry about the little mistake there. So now, let's see here. So we got 0, 1, 2, 3, 4, 5. We have 32, 34. Subtracted from 12, 13. So we got 1, 21 in decimal. That's what we should be looking for. That's here. 0, 1, 2, 3, 4. So we got 16, no 8, 4, plus 1. 21, so that kind of checks our work out there. So that covers our binary number system problems, and then we'll start here on the hexadecimal system. So the next topic that we want to explore is the hexadecimal number based system. So really the big issue with binary number systems when we're working with computers is its verbosity, right? It takes a lot more elements, right? Components, digits, what you want to call them, to represent a value, right? Then it does, say, with decimal, and so on and so forth. Now, since there's sort of this natural relation between binary and hexadecimal, where we can represent 4 binary digits, right, with 1 hexadecimal digit, there's just this natural relationship, so it becomes easy to use hexadecimal to make very compact notations. And that's kind of what we're going to explore here. So we're going to, if you recall, hexadecimal system is base 16, right? And it has our digits of 0 through 9 from decimal, and then we add to it A, B, C, D, E, and F, right? Ampersand's not as simple, but hopefully you get that. And then again, it's just like any number system, right? You always have to go back and think, what is the next largest value that I can represent in that system? So obviously, binary, it's 0, 1. Well, and then I have to go to the next position over, 1, 0, and then 1, 1, and then 1, 0, 0, and 1, 0, 1, and 1, 1, 0, and 1, 1, 1, and then 1, 0, 0, 0, right, for 8, and then 1, 0, 0, 1 for 9, and so on and so forth. For decimal, same thing. I count 0 to 9, and I say, well, I don't have any other digits, so I go 1, 0, 1, 1, 1, 2, 1, 3, right, for 11, 12, and 13. Same thing for hexadecimal. I go 9, but in hexadecimal, I have extra symbols. Whoops, I have extra symbols available to me to use. So no longer do I have to just go 1, 0, 1, 1, 1, 2 because I'm in hexadecimal. I can simply say 8, 9, A, B, C, D, E, F, then 1, 0, 1, 1, 1, 2. The 1, 9, then 1, A, 1, B, 1, C, the 1, F, then 2, 0, the 2, 9, 2, A, and so on and so forth. So that's kind of what we have. And it's interesting from that perspective, and it helps us when working with computers. So let's see here. How do I want to do this? When I want to, let's just take the examples from your worksheet. That's probably the easiest way to do it, so I don't take you on a tangent. The first problem you had in there was to convert 110 1100. Okay, so in order to do hexa or binary to hexadecimal conversion, we group these off in the 4s, all right, from right to left. And so here is there's one grouping of 4, and then we can put an implied 0 there to kind of get our next grouping of 4. All right. And we just map each of these values to their hexadecimal version. And if it helps, I would just say try to memorize a chart, because I know here, I know that's my 0, 1, 2, and 3 if I consider them separately. So it's 8, that's my 4, 9, 10, 11, 12. All right, so I know A is 10 in decimal, B is 11, C is 12, right? From my decimal, 13, 14, and 15. Right? So I just take, I know this is 12 in decimal, and I go up here, 12 in decimal is C in hex. So to get the C, I can write the C there. And I know over here, 0, 1, 2. So I know here this is 4, and then I know that's 2 more, so 6, and I can just write that as 6 straight up. So I know that this gives me 0x 6c in hexadecimal. Right. Let's see here. If I next want to try to do go the other way, go from hexadecimal to binary, for instance 1A7, it's pretty easy. I can just take each value and write the binary equivalent of it. So put that the significant digit down. If it helps, write the leading zeros, right, at the beginning. So there's 1. Put some little marks between it. Put A. Well, my A I know is my 10. Well, what's my 10 in binary? Well, if it helps, you might want to, at this point, or before you even get started, really, you could write a chart down, right? You could, kind of help yourself with this. You could do an entire chart at this point. 0 in binary, right? And you could just, and then let's write these out. Oops. Hopefully I got these right as I went down and did them. Alright, so here's doing 2, here's decimal, and then we'll leave out octal for the time being, and then we'll do decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And in hex, it's going to kind of be the same here for a bit. But we change symbols, right, because we're in hex now. And there we go. A through F. Alright, so now A, I come down here, I know that's 10 decimal. I know that is 1010 in hex. And then I put my 7 to 7 is then 111, right? So now I can write out the entire number. So it's 1, 1010, 0, 111. I should put my leading 0 up there too. So there are groups of 4 exactly. And that's it. I could put a little b there, I could put a base 2, or put a b at the end, or I could put a base, alright, base 2, whatever. So I really can tell it's binary if I wanted to. Let's see here. And hopefully you kind of get the gist of that. Alright, let's see here. And again, if I wanted to do, say, let's say I wanted to do hexadecimal, right? Just show you going to decimal. So here, what I can do is I can say, again, 16 to the 0, 16 to the first, 16 to the second, right? So here, and that's sort of my 256 place, right? And then 16th place and all that fun stuff. 1 times 16 to the second plus 10, really, times 16 to the first plus 7 times 16 to the 0, right? So 256 is 16 squared plus let's see here, the 10 times the 16, 160, plus the 16 to the first is 1 plus 7. So let's see here, that should give me the 3, carry 11, 12, carry 423, right? So yeah, I think making sure I look over that, that is correct. Right. Check. Yeah. All right. Let's see here. Okay, so the next topic is converting a decimal value to hexadecimal. So let's say we want to convert 333 in hexadecimal, all right, or decimal, sorry, and we want to know what it is in hex, okay? So we'll use division by 16 method and repeated division by 16 at that. So we'll take 333, divide by 16. This is sort of our division call. And 16 goes into the 33 twice. And that gives us 32. And then 13. 16 won't go into that 13 again. So there's our zeros. There's our quotient column there with my bad handwriting. And then let's see here, that gives us a remainder of 13 then. Try to kind of separate these a little bit. And then we want to convert this decimal value into hexadecimal. And we'll just keep tacking on values to the left of this for each division through. So if you go back, I don't know, do I still have it or not? We kind of know everything 0 through 9 maps the same. Well, we know 10 is A, we know 11 is B, we know 12 is C, we know 13 here is D, 14 is E, and 15 is F, right? So we'll just recreate that little bit of the whole chart. And so we just put a D there. Okay. So now we're going to take the next quotient. We're going to divide that value by 16, and I'll go in there once, all right, for our quotient, and it'll give us a remainder of 4, and that just is 4, and we'll tack that in front of the D, and then we'll come down here again. We'll take our 1, we'll divide by 16. Again, that won't go in there, so that gives us a quotient of 0 there, and that gives us a remainder of 1. So 1 for D. And again, row 1 and 2, we could check our work. Again, I would encourage you to do so. Alright, I'll leave that as an exercise for you. Let's say we want to convert 800 in decimal to whatever it is in hexadecimal, okay? So there's the question mark there, base 16. Alright, so let's see here. Let's do the division by 16s again. Alright. I keep spelling division wrong. Just realized that. Alright, so there's division. Alright, so 16 is going to go in there 5 times. 5, 0, 8, 30, yeah, 8. So 5, and that actually goes in there evenly, so that's 50 on the quotient. And then let's see here, our remainder n is 0, so our hex number is going to be 0 to start. Alright, so then let's take 50, divide that by 16, that'll go in there 3 with the remainder. It's 48, so a remainder of 2. Alright, and so now we have 2, 0. And then we'll take our 3 here, divide that by 16, we'll go into it, it'll give a remainder of 3, so 3, 2, 0. And I should have kind of rewrote this as 0x 1 for D above, or as 1 for D base 16 here. And down here, I'll do the same, right? It is 0x 320, or 320 base 16. And I think we'll move on to hexadecimal addition and subtraction next. So let's go through our next topic, which is hexadecimal addition and subtraction. So we have the 2 problems from the worksheet that you can download from our course website. We have our mini chart over here for decimal and hexadecimal conversions. So let's go ahead and work through each of these. So take the first problem, take the 16th column here. So we go A, so we go B, C, D, E, F, and then we need one more. So 1, 0 is the next smallest value we can do. So I put 0 here, we carry our 1. 2 plus 1 is 3, plus 1 is 4, right? So now we have 8 plus C, so going from C, it's easier. D, E, F, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. And it's okay to count with your fingers, right? I am not a very fast person when it comes to just doing basic arithmetic. I was nowhere near the fastest person in the good old math board races when I was growing up. That's probably more of a Gen X thing from old math classes than anything else. I don't know if it's still done. But anyhow, so we have that 4 there, and we still have to carry 1 and add it to our just our leading 0 that isn't written down, but it's still there. So there's 1. So 0x1440. All right. Or we can write it as 1440 base 16. All right, come over to the second one. Again, we'll start adding. 9 plus 1 is A, not 1, 0. All right. And then we have, we don't carry anything because we're in hexadecimal. So now we have D plus 5, so E, F, 1, 0, 1, 1, 1, 2. Right? So we have the 2 there. We carry 1 in that case. And then we have F plus 1, which is our 1, 0, plus 1, 1. And then we carry 1 over into our next column of zeros, right? So we get 1. So OX112A or 112A base 16, subscript 16, right? Or sub 16, however you want to say it. Okay, so let's do the few subtraction problems. So 24F minus 52. Right. So here we go. So F, so we subtract 2, ED, right? Well, actually it's not in frame. ED, right? Start F, subtract off 2, we get D. Now we can't subtract 5 from 4 there, so we need to borrow, make that a 1. I write down 16s to help me think, so 16 plus the 4, the 20 minus the 5, 15 in decimal, 15F. And then the 1 minus the implied 0 there is just a 1, right? So 1FD sub 16 or OX1FD, right? However you want to do it. Next one would be 3002 minus 6F, right? And let's see here. So there we can't subtract F from the 2, so we need to keep going over till we can borrow. Make that a 2, 16, 15, and then 16, 15, and then we have 16 here. So we add 16, 18, right? Our F is 15. So it really is a difference of 3 there. So we just write our difference of 3. And then we have 6 from the 15, 9. Let's see here. And still 9 hex. And then 15 leading 0 will be F again. And then 2 minus the, because we have the implied zeros here, 2. So OX 2F93 or 2F93 sub 16. All right. And then finally, over here, we're going to have 9E2 minus 2D. And then again, we'll just kind of go through here. So D, we can't subtract D from 2, I'm sorry. So we will decrease that column by 1, put a 16 there. It gives us an 18 work with minus the D, which is 13, not 14. So it gives us a 5. And then we have D subtracted from 2, 1, 2, B. Oh, sorry, can't see it, 1, 2. All right. So we got a B there. And then we have 9. So X9, B5. So hopefully that gives you sort of the basic run through of going through the practice sheet. You have several homework assignments, really just 2 attached to the number systems that you need to do and submit. And if you got other questions, just let me know, and I will answer them. If I need to post video, I can. All right, take care.